You can freely download this practical notebook from my website. From its home page, go to middle left and click Books and Notes. A new web page will open. Then download third book in PDF format. Experiment 6 Part A in the practical notebook. Left side page of same experiment.
Good morning, students. Today we will perform experiment number 6. The topic of the experiment is to find the value of acceleration due to gravity by oscillating mass spring system. For calculating the value of acceleration, we will use the apparatus helical spring, slotted weights with hanger. Okay, you can easily see this is the helical spring in which we will produce the extension. These are the slotted weight. This is the first one, including hanger. This will carry 50 gram weight, and these are the extra weights, each of carry 50 grams. And this is the scale on which we will take the reading or extension in the spring. Let's start the performance. This is the helical spring, and this is the weight, and this hanger including this pointer weigh 50 grams. I will add more 50 grams in this. Now this becomes totally 100 grams. And we easily observe that the extension in spring is produced. Either it is slightly, but because it is directly proportional to the force applied. Now we will observe the initial reading of the pointer on the meter rod and put it on the table, which is 1.90. Now we will add one more weight. This weight also carry 50 grams, and extension in the spring easily observed. So we will note this extension as well as reading on the meter rod with this pointer. Now the total weight of the pointer is 100 grams. With performance, the initial position of the pointer was 1.90, and after applying weight of 100 grams in the spring, the extension was produced, which is 2.35 centimeter. And in units we have to be so careful because we have to take all the readings in the same system of unit. If we are taking the weights in grams, then extension must be in centimeters. This is the oscillating mass spring system. So this spring can be oscillate on its axis, and we will note down the time for 20 vibrations. You have to slightly disturb the weight and spring start to oscillate on its axis. And you can take the reading for 20 vibrations. And with the same movement, you have to start the stopwatch. So before starting the stopwatch, we will check the oscillations of this spring by moving this weight slightly. And where the oscillations will start smoothly to move, then we will note down the reading from the stopwatch. So first of all, we have to check the oscillations. This pointer should not touch the meter rod, and this spring is free to move about its axis. So you should be so careful about these two things. While the oscillation starts to move smoothly, we will start the stopwatch from 0 value and note down the value for 20 vibrations. After 20 vibrations, we will stop the stopwatch and note down the value. What we observe from the performance, that time for first time 20 vibration is 6.1 second. We have repeated the same value in the same weights, and second time we observe 6.2 second, and we have taken the average of these two values, which is 6.15, and as this value is for 20 vibration, so we have to calculate the time period, which will be observed by time divided by 20. And this time period will give us the time of one vibration, which is 0.3075. We will take the scale of this time period, and we have to, according to our statement of the experiment, we have to calculate the value of G. So according to mass oscillation of mass spring system, the formula of gravitational acceleration is this, in which we have to put down the value of extension of the spring, which we have already observed in the start of the experiment, and substitute the value of time period of the oscillating mass spring system, and calculation will give us the value of gravitational acceleration, which is 975.57 centimeter per second scale. Similarly, by performing the same procedure, we will take two more values by changing the waves in the slotting hanger and take the time period in the same procedure, calculate the value of G. After that, after completing three values, we will take the mean value of G, which will be in the centimeter per second scale. Now the actual value of the G is 980 centimeter per second scale, and calculated by the performance, the value of G is this. After completing our procedure, we will take the percentage error. After the mishandling of the apparatus, first one is this: the pointer should not touch the meter rod. This is the very wrong procedure to attempt the performance. You should not hang the hanger in this way. Second one is this: the pointer should not be much far away from the pointer that you cannot observe the reading properly. Thirdly, the spring must be free to move. So you should check the rust and dust in this spring, and you have to clean this spring. Last one, that your meter rod must be in front of you, that you can easily observe the reading, and it must be free of dust and dust, and readings are too much clear on the spring meter rod. The last and most important precaution about this experiment, that how you can use the stopwatch. First of all, you have to check how we can use this. This is the reset button, this is the start and stop button. So first of all, you have to reset your stopwatch, and it will show the reading 00 on its display. After that, you can check its start button. It starts counting the seconds, and when your oscillations are complete, you can easily stop this by using stop button. And after taking one reading, you can also reset it on its zero value.
You can take this objective physics practicals from Ilmi Book Depot, Urdu Bazaar, Lahore, or you can download directly from my website. Your readings may be different from these readings. Check these readings as a reference. Thank you.